Hi everyone, welcome back to this GCSE Chemistry session as part of the My Tutor online school. It's the last session of the day, so it will last 1 hour from 3:15 until 4:15. My name's Aman and I'm the GCSE Chemistry tutor. Today we'll be covering alkenes, alcohols, carboxylic acids and esters. So we'll be carrying on from where we left off yesterday. So yesterday we started looking at alkenes. Today we'll be looking at their reactions in more detail. As I said, I'm the chemistry tutor and I study medicine at King's College London. If you've partaken in these sessions before, you'll know who I am, and I'm sure you've met me loads of times before. As usual, any questions that you have, please put them into the Q&A or the chat box function, and I will try and respond as I'm going along. Today there's quite a lot of content, but the content's more kind of drawing structures, so I'm going to focus on that rather than exam questions today, but tomorrow we'll try and do lots of exam questions. I do have a quiz that we'll do at the end, but as I said, my focus isn't really on exam questions today, but we will do a quiz at the end. So let's start. So hopefully you can see the learning objectives for today. So they should be on the screen now. So our learning objectives will be understanding the combustion reactions of alkenes. We need to know the reactions of the first 4 alkenes. So that's ethene, propene, butene, and pentene with halogens, hydrogen, and steam. We need to be able to draw the first 4 alcohols, be able to draw the first 4 carboxylic acids, and be able to draw ethyl ethanoate, which is an ester. As I said, quite heavy on the content today, but it is mainly structures that we'll be drawing. I won't be going into the properties of all of the groups. So can you all see my screen? Can I just check that you can see my screen? Can you see the learning objectives? Okay. You can see my screen. Great, that's fine. All right, so let's just recap what we covered yesterday. So we need to write a combustion reaction for methane. Sorry that you can't see that. So combustion reaction for methane, it's complete combustion. What's the chemical formula for methane? Does anyone remember? What's the chemical formula for methane? So it's the first alkane. Good, CH4. What does it produce when it undergoes complete combustion? So CH4, what does it react with and what does it produce for complete combustion? Good, it produces carbon dioxide and water. That's complete combustion, excellent. And what does it react with to produce that? So it's a complete combustion reaction, great, oxygen. So the reaction is CH4 plus oxygen, complete combustion to produce CO2, carbon dioxide and water. And that's complete combustion. Remember, the incomplete combustion tends to produce carbon monoxide or carbon. So we need to balance this equation. So if we have a look, there's 1 carbon on the reactant side, 1 carbon on the product side. There are 4 hydrogens on the reactant side, but only 2 on the product side. So if we put 2 in front, then we end up with 4 hydrogens. If we then look at our oxygens, there are 2 on the reactant side, but on the product side, there are 2 plus 2, which is 4, so we just need a 2 here. So that is a fully balanced equation for the combustion reaction of methane. If you've got any questions about complete combustion, please head back to yesterday's webinar where we go over complete combustion and incomplete combustion in lots of detail. The second question is, what is the test for a carbon double-double bond? So does anyone remember a carbon-carbon double bond? What's the test for it? We will be doing a quiz at the end for the person that's asking me. So what's the test for a carbon double bond? Excellent. Bromine water will turn from brown to colourless. Yep, so you can say brown or orange, but it will turn from brown or orange to colourless. Excellent. So remember, alkanes don't have that double bond, so they will not react with bromine water, whereas alkenes have that double bond, and so they will react with bromine water. Excellent. Well done, everyone. So today we'll start off by looking at the combustion reactions of alkenes. And what's really important is that when alkenes combust, they will tend to undergo incomplete combustion. So that means they will tend to produce carbon monoxide or carbon and water. So remember, water is always produced, but if it's incomplete, you will either get carbon monoxide, so one carbon, one oxygen, or carbon. And we went through the dangers of those yesterday. So because it's incomplete combustion, we tend to burn with a smoky yellow flame. So the more incomplete combustion is, the more smoky a flame that is produced. So with alkenes, when they burn, it tends to be incomplete. So on the screen, we've got the incomplete combustion of which alkene? C3H6. Which alkene is C3H6? Good, it's propene. So on the screen, we've got the incomplete combustion of propene. So let's have a go at doing the incomplete combustion of butene and ethene. So if we start with doing butene first, and we'll do butene producing carbon monoxide. So that means butene is C4H8. So remember, the general formula for alkenes is CnH2n. So C4H8, it's going to react with oxygen, as all combustion reactions. And because it's incomplete, I've told you it's going to produce carbon monoxide and water. And then we just need to balance that. So we've got 4 carbons on the reactant side, so we put 4 on the product side. Then if we look at our hydrogens, there are 8 on the reactant side. So that means we need a 4 on the product side. 4 times 2 is 8. Then we just need to look at the oxygens. So there are 4 oxygens here and 4 oxygens here. That makes 8 on the product side. On the reactant side, there's only 2, so we put a 4. So that is a fully balanced equation for the incomplete combustion of butene to produce carbon monoxide and water. So now let's try ethene and ethene to produce carbon. So what's the chemical formula for ethene? What's ethene? What the formula for ethene? So ethene is the first alkene. Good, C2H4. And remember, it's the first alkene because methane can't be produced because methane only has 1 carbon atom. And to produce that double bond, there has to be at least 2. So that's why ethene is the first. Ethene will react with oxygen. I said it's going to produce carbon. So carbon and water. And as in exam questions, they will always tell you what's produced when you undergo incomplete combustion. They won't tell you if it's complete combustion. So if they say complete combustion, then complete combustion, you need to be able to do carbon dioxide and water. If they're saying it's incomplete, they will tell you the products. So I just did butene for the person that's just asked me. So I just did butene producing carbon monoxide and water. So butane is C4H10. Butene is C4H8. Remember, the alkenes tend to undergo incomplete combustion. Someone's asking me, are alkenes on the periodic table of elements? No, but their individual components are. So remember, alkenes are hydrocarbons. That means they're made of just carbon and hydrogen, just like the alkanes, only made of carbon and hydrogen. So carbon and hydrogen will be on the periodic table, but the individual alkenes and alkanes won't. So let's balance this equation then. We've got 2 carbons on the reactant side, so we need a 2 on the product side. Hydrogens, 2 on the reactant side, so we need to put, 4 on the reactant side, so we need to put 2 on the product side to make it 4, so 2 times 2 is 4. When we look at our oxygens, there are 2 on the product side and 2 on the reactant side, so that's a fully balanced equation for the reaction of ethene. Any questions on the incomplete combustion of alkenes? So on the screen, we've done butene and ethene. I already had their propene. So you'll tend to be asked about the first 4 alkenes. So that's ethene, propene, butene, and pentene. And as I said, they will tell you what's produced. Okay, if there's no questions on that, we'll move on to the first reaction that we need to know, and that is reactions with halogens. Someone's asking, can we be asked about any other alkenes? You can be asked about them. And all you would be expected to do is write in the products. So they would never expect you to, if someone said, oh, let's say octene, they wouldn't expect you to know that that is C8H16. They would write that there for you and they would say it undergoes incomplete combustion, fill in the products, and it will say that, for example, it produces carbon monoxide. So they will tell you, and again, you will need to balance the equations. So the hardest part that I always find is balancing the equations. But if you remember the rules that we went through yesterday, if you start with carbon, then do hydrogen, and then do oxygen, that's kind of the best way that I always find with balancing combustion reactions. So as I said, you need to know the first 4 alkenes: ethene, propene, butene, and pentene. You need to know their combustion reactions, which are all incomplete, but they will tell you whether it produces carbon monoxide or carbon, and water is always produced. And if they give you a different alkene, they will either give you the formula for it or tell you how many carbon atoms are in it, and then you just need to work out the number of hydrogen atoms. But if you remember the general formula, CnH2n, then you should be able to work out the alkene. Any other questions on that before we go through the reactions with halogens? Someone's asking me, are halogens group 7 or group 2? They are group 7. Remember that group 2 is a metallic group. So group 2 is on the left-hand side of the periodic table, so it'd be metals. What are we going to cover today, and are we going to do any cracking? So we covered cracking yesterday, so we're not going over cracking again. Today we are looking at the reactions of alkenes and hopefully looking at the structures of other types of the groups, so esters, carboxylic acids, and alcohols today. Okay, so let's look at the reactions with halogens. So we've talked about incomplete combustion. When we talk about halogens, the only group that will react with halogens are alkenes. Alkanes will not react, and the reason for that is because of the carbon-carbon double bond. So you need to have that double bond for the alkene to be able to react with a halogen. And for all the exam boards, you need to know the reactions of the alkenes with 3 halogens, and they are iodine, chlorine, and bromine. So iodine, chlorine, and bromine. This first statement here talks about what's produced. So it's a dihalogen alkane. So if we just have a look here, dihalogen, iodo, ethane, alkane. Here, dichloro, that's the halogen, butane. So what's really important is that you start off with an alkene. So we've got ethene here. It reacts with a halogen, but then what happens is it becomes a saturated molecule, diiodoethane. And I'm going to draw that out just to explain what's going on. So first of all, if we start with ethene, so we've got a double bond and 4 hydrogens. And remember, it's unsaturated, and that's because of that double bond. If it was a single bond, we would have more hydrogens in it. So that's ethene. It's going to react with iodine. And what happens is when that iodine reacts with it, it breaks that carbon double bond. And so essentially you end up with a single bond, and in its place, we put an iodine. So what's formed then is an alkane. And the reason for that is there's no double bond. And so what we call that is diiodo, and that's because there are 2 iodines on there. So di, that means 2, diiodo, ethane, and that's because it's now become an alkane. So that's where the name comes from. If we look at butene, it's butene plus chlorine. Again, the chlorine is going to add itself onto that double bond so that it becomes a single bond, and we form dichloro, so 2 chlorine butane. And the product for that would be this, single bond. Like so. And so that is dichlorobutane. So 2 chlorines and butane there. Any questions on that at all? So they all do the same. And as I said, you need to be able to know about iodine, chlorine, and bromine. You don't need to know the other halogens. Someone's asking, if you have ethene, for example, and have chlorine and iodine react with it, would chlorine react with ethene as it is more reactive than iodine? So that's a really good question. So that kind of relates back to what we did a couple of weeks ago about the reactions of halogens and how the higher up halogens are more reactive than the lower down halogens. Yes, so it will react with the chlorine. You won't ever get asked that in a GCSE question, but a really good question, thinking outside the box there. So good job. Any other questions at all about ethene, butene and reactions with halogens. We're going to have a go at doing a couple of examples. The other points on this slide say that they're spontaneous reactions, and that just means that it's quite reactive. So remember yesterday we covered that the carbon double bond has 2 electrons in it, and that makes it quite a reactive bond. Anything else? Any other questions on that? How many alkenes are there? Really good question. So there's actually quite a lot of alkenes because the number of carbon atoms that you put into that alkene will determine it. So I'm going to say infinite because remember that alkenes are just a certain number of carbon atoms with a certain number of hydrogen atoms. So you could essentially have an infinite number of carbon atoms. Someone's asking, are certain alkenes more reactive, like a reactivity series? Really good question. So you will learn about this at A level. The important thing that you need to know is that the double bond is what makes it reactive. So you don't need to know about our reactivity series. You just need to know it's the double bond that makes it reactive. Okay, so let's have a go at drawing doing some of these. So on the screen, we've got ethene reacting with iodine and butene reacting with chlorine. So let's do pentene reacting with bromine. So what's the formula for pentene? Formula for pentene. Good, C5H10. So we start off with C5H10. I'll draw it out again. So C5H10. And just remember when you are drawing these out to count the number of bonds. So there shouldn't be more than 4 bonds because carbon can only form 4 bonds. So if we have a look at our double bond in particular, this carbon has 1, 2, 3, 4, this carbon 1, 2, 3, 4, this carbon 1, 2, 3, 4, and 4, and so on. So just make sure there's always 4 bonds. So now what's going to happen is it's going to react with bromine. And so the bromine is going to replace the double bond. So what we essentially form is this. So can someone try and name it for me? So we've got pentene reacting with bromine. So what will the product be called? So I'm drawing it out. What will the product be called? Okay, so what you can see is the double bond's gone, and in place of that double bond, we've got 2 bromines there. Excellent, dibromopentane. Brilliant. So the person that said diiodopentane, the reason it's not iodo is because we've added bromine. So it's dibromopentane, not pentene, because remember we formed an alkane. So dibromopentane. Excellent job. Well done. Are there any other halogens that we need to be familiar with except iodine and chlorine? So you need to know about fluorine as well, not in the context of these reactions though. With these reactions, you only need to know about iodine, chlorine and bromine. With all the other topics that we covered when we did the halogens, you needed to know about all of them, but in this case you don't. Okay, great. So do you want to do another example of a halogen reaction or are we happy with that? So we can do propene reacting with iodine, for example. Happy with that? Okay, great. So just as a recap, the alkenes react with halogens. They will form a dihalogen alkane. So in this example, ethene reacts with iodine to form diiodoethane. Butene reacts with chlorine, dichlorobutane. And if it's bromine, it's dibromo plus an alkane. So someone's asking me to go through another example, so I will go through another example. So let's do then propene. Let's do propene reacting with chlorine. So we've got propene. I won't draw it out this time, so we'll just write it out. So we've got propene. It will react with chlorine. What will the product be? Remember, halogen alkane. So what will the product be? Propene and chlorine. So it's going to break that double bond. We're going to add the chlorine onto that double bond. What will the product be? Excellent. Dichloropropane. Good. So the di is 2 chlorines have been added. The propane, because it's an alkane, and it's chloro, because it's chlorine. Excellent. Well done, everyone. Okay. So the second reaction we need to know about, so far we've looked at incomplete combustion of alkenes. Remember, all the alkenes undergo incomplete combustion. We've talked about the reactions with halogens. The next reaction is a reaction with hydrogen. And I like this one the most because I think it's the easiest one to understand. And all it is the alkene reacts with the hydrogen to form an alkane. And the reason I find this the easiest to understand is because if we think about an alkene, let's think about ethene. The only difference between ethene and its alkane, ethane, is 2 hydrogens. Okay, can you see that? The only difference between ethene and its alkane, ethane, is 2 hydrogens are missing. So the reason I like this reaction is because it makes sense to me. So we add hydrogen to an alkene, we form an alkane because we've just added in that hydrogen that's missing. So these reactions for me are the easiest to understand. The only thing you also need to know about is in what conditions these reactions take place. So they tend to need a nickel catalyst and they need to be put at 60 degrees. So all that's happening is we're adding in hydrogen, they need a nickel catalyst at 60 degrees. So I've done ethene producing ethane. On the screen you've got propene and hydrogen to produce, sorry, that should say propane. And pentene plus hydrogen to produce pentane. And then the other one that we can do is butene. So what's the formula for butene and what will it produce when it reacts with hydrogen? Formula for butene and what will it produce when it reacts with hydrogen? Good, so butene is C4H8, not C6H12. C6H12 is hexene, so butene is C4H8. It reacts with hydrogen to produce what? What does it produce? Excellent, butane. So the person that's given me the full reaction there, well done. You don't need to balance it. It will all be balanced for you already, because if you have a look, all you've done is added in those 2 hydrogens, so it's all balanced. Great. Any questions on the reactions with hydrogen then? Someone's asking, would an isotope of hydrogen affect this reaction? You would never be asked to use an isotope of hydrogen. You would be using hydrogen gas, H2, not an isotope. Are chlorine, bromine, and iodine the only halogens that can produce a precipitate with hydrochloric acid and barium chloride? I'm not sure what you're asking there. Are chlorine, bromine, and iodine the only halogens that can produce a precipitate with hydrochloric acid and barium chloride? Again, I'm not sure what you're asking me there, so if you can rephrase that question, I will try and answer it for you. Okay, so far we've looked at incomplete combustion, the reactions with halogens, and the reactions with hydrogen. Before we look at the next reaction, we're actually going to look at alcohols and just understand what an alcohol looks like. And you'll understand why I'm looking at alcohols first when we come to the next reaction. So we've looked at alkanes and we know that they have a general formula CnH2n plus 2. That's alkanes. We've just been looking at alkenes and we know alkenes have a general formula of CnH2n. The next group is an alcohol, and alcohols have this formula here, CnH2n plus 1 OH, and it will make sense once I draw them out. When you have a hydrogen reaction, do they explode or stay still? I'm not sure what you're asking me there. So in these reactions that we've just been looking at, they're not that explosive. They are reactive because it's a double bond, but they don't tend to explode. Okay, so let's look at an alcohol. So as I said, you need to know the first 4 alcohols. In this case, it's methanol, ethanol, propanol, and butanol. And the reason methanol is an alcohol is because alcohols don't have a double bond. So that means methanol is the first one. So I'm going to draw out each of them. So we'll start with methanol, which is CH3OH. So remember, methane will tend to be CH4 like that. In an alcohol, the only thing that's replaced is one of these hydrogens, and in its place you will have an OH bond like so. So the alcohol group has this OH bond. That's what makes it special, the OH bond, and all it does is replaces one of the H the H bonds that are there. So that's why it's actually come from an alkane instead of from an alkene, in that there's no double bonds there. So if we draw ethanol now, ethanol has 2 carbons. So you have CH3. And on this one, we would have 3 hydrogens, but as I said, the OH bond replaces one of those hydrogens, and so that is ethanol. I'm just going to take a pause there and just explain these 2 different formulae. So at GCSE Chemistry, you can write out the formula for ethanol in 2 ways. You can either do it by the bonds that you see, or you can do it by the number of carbon atoms and the number of hydrogen atoms. I prefer to do it by the bonds that you see. So what I mean by that is, if we have a look at ethanol, there is CH3, CH2, OH. So that's this one here, CH3, CH2, OH. The other way to do it is just to count up the number of carbon atoms. So C2, then the number of hydrogens. There are 5 hydrogens, C2H5, and then put the OH bond, which is this one. So you can do it either way at GCSE Chemistry. Chemists prefer this way here, and that's because that helps them to draw it out. So if someone said to me CH3, CH2, OH, I know how to draw that out, because you just go left to right. So you do CH3, you then bond that to a CH2 with an OH on it. Someone's asking, for GCSE exams, what do we need to know about alcohols? That's a really good question. So for today, you just need to know the structures of alcohols and how they're produced, which we will cover. Tomorrow, we will go into the reactions of alcohols in lots of detail. But for today, we just want to know the structures of them. Someone's asking, do we need to know both ways for the exam? I don't think so. I know AQA doesn't ask you to know both ways. They will take both answers though, as in you can give either or. But definitely if you go on to do it at A level, you need to know the way that I prefer, so the one with the arrow here, because that's the way that is mostly used. So if you can get into the habit of doing it this way, I would suggest doing that. Someone's asking, how are alcohols formed? Really good question. We're going to go into that in the next slide. The reason I didn't cover that first is because I just wanted to make sure you all knew what an alcohol looked like, but we will go into that in the next slide. So when testing for the presence of halogens in a compound, I think you add hydrochloric acid and barium chloride into the solution with halogen ions. So if you want to know the answer to that question, if you go back to a couple of weeks, we looked at halogens in lots of details and the reactions there. There is a quiz today, and the quiz today will be done at the end of the session, and they are all molecular bonds, so they're covalent bonds. And the reason they're covalent bonds, or that it produces a molecule, is because carbon and hydrogen and oxygen are all non-metals. So remember, between non-metals, it's covalent bonding. Okay, so I've drawn methanol up here. Here's ethanol, so now I'm going to draw propanol. So propanol has 3 carbon atoms, so CH3, CH2, CH2, OH. And if you have a look, that's what I've written here, CH3, CH2, CH2, OH. And as I said, the other way would be 3 carbons, 7 hydrogens plus the OH. So if you are doing it this way, just remember when you're counting up the hydrogens, don't count up the hydrogen that's part of the OH bond, because that will always be separate, and that's what denotes it as an alcohol. The quiz will be on everything that we've covered today. Okay, so the final one we need to draw is butanol. So again, CH3, CH2, CH2, CH2OH. And just to say, I had a really good question yesterday asking me, what does butan 1-ol, butan 2-ol mean? You will cover that at A-level chemistry, but it's essentially isomerization. And basically what it's saying is that this OH bond could be put anywhere. I've put it onto the first or the last carbon in all of these cases, but you could essentially put it onto the second carbon, in which case it would be butan 2-ol. This at the moment is butan 1-ol, not butan 4-ol. And the reason for that is that technically this could also be the first carbon. So that's why it's butan 1-ol. But again, I'm not going to go into too much of that. Is butanol a double bond? No, they're all single bonds. They're all single bonds. How would you write this? Butan 1-ol. Yep, the person that said it, you've written it correctly. But as I said, you don't need to know that at GCSE, that is A level. Okay, any questions on alcohols and their structures? So we've gone through all 4 alcohols. All I want you to be able to understand at this point is that it's the OH bond that denotes the alcohol and that you're able to draw them all. This is not higher, this is foundation. No questions on that? Okay. So at this point, I'm just going to recap what we've covered so far, and then we'll go on to new content. So we started off with incomplete combustion of alkenes, and we said that all alkenes undergo incomplete combustion to produce either carbon monoxide or carbon and water. We then went on to look at the reactions of alkenes with halogens, and when they react with halogens, that's chlorine, iodine, or bromine, they produce the dihalogen alkane. So butene plus chlorine will be dichlorobutane. And then we've now been looking at then we looked at the reactions with hydrogen, which is the one that I like because it makes sense to me. So we add propene to hydrogen and we get propane. We add pentene to hydrogen and we get pentane. So when we react with hydrogen, the alkene becomes an alkane. And again, that double bond is breaking. So these could all be higher questions. It will just depend on how the question is phrased and what you're asked to do. So when I say it's foundation, I mean that it's in both the foundation and higher tier papers. Organic chemistry tends to be about a grade 6 or 7. So you would see it at the end of a foundation paper. Then we went over the alcohols and we looked at the structures of all of them. So the next thing we're going to do is look at how alcohols are formed. And this is the third reaction that we need to know about for alkenes. So alkenes will react with water, specifically steam, at 300 degrees in the presence of a catalyst to produce an alcohol. So the reason I didn't do this first is because I wanted you to just understand what an alcohol looks like. Now that we know that, we can go through this reaction. The key thing is that it's a reversible reaction. So in exam questions, what can often happen is that they will do a question on organic chemistry of alkenes reacting with steam, and they will link it in to the topic that we did last week, so rates of reactions and equilibrium, and that's because it's a reversible reaction. So the word alcohol, the reason it's there is it's because of that OH bond, so they'll be named because of their bonding. This is all the exam boards. The only one which we'll cover in a bit that isn't on AQA is to do with esters. So this is all the exam boards at the moment. Okay, so reactions with steam. As I said, alkenes react with steam at 300 degrees in the presence of a catalyst to produce an alcohol. It's a reversible reaction, so it tends to link with equilibrium reactions. So let's look at the first example. Pentene plus steam will produce pentanol. Ethene plus steam will produce ethanol. So let's try and do butene plus steam. What do we think butene plus steam will produce in a reversible reaction? Butene plus steam. Excellent, butanol. And what about if we do propene plus steam? What will that produce? Propene plus steam. Good, propanol. So when we react an alkene with hydrogen, we produce an alkane, but when we react it with steam or water, it produces an alcohol. So that's how alcohols are produced. We will also look at fermentation tomorrow, which is another way of producing alcohols, but today we're just looking at reactions of alkenes. Someone's asking me about empirical formulae. I'm not sure what you mean, but yes, all of these are empirical formulae, because remember, empirical formula by definition just means that the formula you have there is in the simplest ratio. So if you look at pentene, C5H10 is not an empirical formula, it's not an empirical formula because you can divide by 5 to make CH2. Whereas something like CH2O5 ethanol is an empirical formula because you can't make that any smaller with regards to the ratio. For the exams, do you need to know what their chemical formulas are? Yes, you do. So C2H4 for ethene, you do need to know that. So as I said, you need to know the first 4 alkanes, the first 4 alkenes, the first 4 alcohols, and the first 4 carboxylic acids, which we're going to go into soon. Any questions on the reactions with steam, or are we happy to move on? Yes, when you change the empirical formula, the alkene will change. That's why we use chemical formulas, not empirical formulae. Empirical formulae comes into the quantitative chemistry that we covered a couple of weeks ago. Good question. You don't need to know the catalyst for this reaction. That's why I've not put it in, because there are lots of different catalysts that can be used. Is there any specific way that you learnt these formulas? That's a really good question. The main way that I learnt it is if you learn the first 4, they all kind of stem from the same names. So for example, you've got methane, ethane, propane, and butane. And the example I gave the other day was that many eat peanut butter. So methane, ethane, propane, butane, many eat peanut butter. And then if you think about the alkenes, you don't have methane, but you have ethene, propene, butene, and pentene. So now think maths, 5 sides makes a pentagon, so pentene. With alcohols, again, methanol, ethanol, propanol, and butanol. So if you remember the first 4, you can usually be able to name them. How would you reverse this reaction now that it is an alcohol? Excellent question. So it's only reversible when it's at equilibrium. So you wouldn't do anything, you would keep it in there, and essentially what would happen is that pentanol would degrade almost or break down into pentene and steam. Okay, someone's asking me what tips would you give in order to pick your A-level, because I'm not quite sure on what to pick. Really good question. So yesterday someone asked me the same question. And the advice I gave was to choose A-level subjects that you enjoy. So by that, I mean, don't go into a subject just because you think you need it at university, for example. Pick the subjects that you enjoyed. So when I was doing my GCSEs, I really enjoyed biology, chemistry, maths, and Latin. So I did those 4 subjects at A-level. And I think probably the best thing that I did was choosing subjects that I enjoyed. So I absolutely hated physics, and so I didn't choose physics, even though I know it's a really good A-level to do. All the A-levels are really good to do, so I think just choose A-levels that you enjoy. Don't choose the ones that you need for a university course, because you'll end up not doing as well as you want to. Okay, so are we moving on then from this? Is everyone happy to move on from steam to carboxylic acids? Okay, so I'm getting lots of A-level questions, so I'll just answer those and then we'll move on. So someone's asking me, which science do you need most to be a doctor? You need 2, you need chemistry and biology. Most universities want chemistry and biology. Do you think we should do 3 or 4 A-levels? The only reason I did 4 was because at the time my school advocated doing 4. I think these days most people do 3. And you don't get penalised if you do 3 versus 4. So if you would prefer to do 3, do 3. 4 is quite a lot of hard work. Yes, I am in medical school. Okay, let's move on to carboxylic acids. So carboxylic acids, again, I'm not going to go through the properties today. I just want you to be able to understand what the structure looks like. Just like with the alcohols, what does it look like? And again, you need to know the first 4. So if we start with methanoic acid, we need to know the functional group for methanoic acid. So it will have 1 carbon. It will then have a double bond in there, and that double bond is to the O. It will then have almost an alcohol bond, and then you have the hydrogen that's left. So remember, there's always 4 bonds. So 1 bond to the hydrogen, a double bond to an oxygen, and then a single bond to an alcohol group. What makes it a carboxylic acid is what I call the COOH bond. So the COOH bond. So remember, alkanes just have carbon-hydrogen bonds. Alkenes have that double carbon bond. Alcohols have the OH bond, but carboxylic acids have the COOH. That's what makes a carboxylic acid. Someone's asking, isn't it better to pick as many subjects as you can because you can see what you would do best in for the future when it comes to getting a job? I disagree. I think at A-level you should pick a few subjects that you enjoy, because A-level is a big step up from GCSE. So I think if you pick subjects you enjoy, you're more likely to focus on them and do well. Which subjects do you need at A level to be a dentist? So usually you always need biology and chemistry, and then the third subject can be anything that you want to do. Veterinary science, again, you need biology and chemistry, and the third subject can be anything that you want to do. So all the kind of medicines, dentistry, and veterinary science want biology and chemistry. Okay, so that's methanoic acid. Let's do ethanoic acid. Again, we've got our CH3, because remember there's 2 carbons, and then the second carbon will have your double O, OH. And just check there are 4 bonds, so 1, 2, 3, 4. So this is here our functional carboxylic acid group. So that's ethanoic acid. I'm now going to draw propanoic acid. So CH3, CH2, C double bond O, OH, like so. And again, that is your functional group. Someone's asking, which job would you recommend if you take chemistry, biology, and further maths? I think it's about doing what you want to study. So at A level, if you study those subjects and you feel like you really enjoy biology and chemistry, then go into something sciencey, something biological, so biological sciences, biomedical sciences, anything like that. If you enjoy the math side, you can study maths, economics, engineering as well. If you enjoy chemistry, there's lots of different subjects that you can cover. Okay, so we've done ethanoic acid, methanoic acid, and propanoic acid. The final one is butanoic acid. Just to say, the way I've put the formulae for these is how I would draw them. So CH3, CH2, COOH, which is what propanoic acid says. You can do it the other way, in which case it would be 2 carbons, so C2, 5 hydrogens, H5, COOH. So you still need that COOH on the end. But as I said, it's better to write it like this. So for ethanoic acid, if you have a look, it would stay CH3, COOH. Butanoic acid will be C3, H7, COOH. And I'm going to draw that out now for you. So the reason it's C3 is because the other carbon is in the carboxylic acid bond. Someone's asking me, do you do another job as a chemistry expert apart from being a tutor? No, I'm at medical school at the moment, so I'm at university. I'm a tutor, and that's it. Okay, so let's draw butanoic acid then. So 4 carbons, so CH3, CH2, CH2, and then C double bond O, OH. So again, there's your carboxylic acid bond. Okay, any questions on carboxylic acids, or are we happy that it's the COOH bond? Someone's asking which job do I aspire to, or which profession do I aspire to go into? I want to be a general practitioner. Okay, so is there a formula? Good question. The reason I've not put a formula here is that it can be a little bit confusing because of the way that we write these. So we don't write, we don't tend to write C2H5COOH. If when you are struggling to find the formula, for example, so if we look at butanoic acid here, so just the actual formula would be CN-1 H2N. So it'd be N-1, sorry. So 2N minus 1 COOH. So as you can see, it's a little bit confusing. So for example, for butanoic acid, there are 4 carbons. So it would be CN-1, C3, H2N-1. So 2 times 4 is 8 minus 1, H7, COOH. For propanoic acid, CN-1 makes 2 because there's 3 carbons in propanoic acid. H2N-1, 2 times 3 is 6 minus 1, H5COOH. I prefer not to use that formula. I prefer to draw it out. Okay. The final thing we're going to cover today then is esters. You learn this in year 11, for those that are asking. So we've looked at alcohols, we've looked at carboxylic acids, we've looked at the reactions of alkenes. The final thing is esters, and then we'll do a quiz before we finish off. So esters are formed from alcohols and carboxylic acids. We're not going to look at that reaction specifically today. It's just if you want to know how they're formed, I'm just going through that. But tomorrow we'll look at it in a lot more detail. So this is where there's a bit of discrepancy between the exam boards. So AQA wants you to be able to draw ethyl ethanoate and no other ester. You are, however, required to be able to define what an ester is, the bond that's involved, and be able to name an ester. The other examples may ask you to draw the other esters, so we'll go through how to draw those now. So first of all, what does an ester look like? So we've seen the OH bond in an alcohol, we've seen the double carbon bond in an alkene, and we've seen the C double bond O OH bond in a carboxylic acid. In an ester, it's almost a mishmash of all of them. You have a C double bond O O bond. So that's the ester bond, first of all, that you need to know about. And it's really important in esters. It can be a bit confusing when you're drawing them. And I think the reason AQA only asks you to be able to draw ethyl ethanoate is because it can be a bit confusing. So I'll draw ethyl ethanoate first. So remember, ethyl ethanoate has two carbons in both sides. And if you're wondering where the name comes from, the first part of the name comes from the alcohol. The second part of the name comes from the carboxylic acid. So if we look at propanol plus methanoic acid, it would be propyl, which comes from the propanol, methanoate, which comes from the methanoic acid. If we look at butanol plus propanoic acid, it's butyl propanoate. So what would methanol plus butanoic acid make? What ester would that be? Methanol plus butanoic acid. The subheading for this slide is esters. Excellent, someone's given me the correct answer. I'll just wait for a few more answers and then I'll tell you the answer. So methanol plus butanoic acid, remember the first part comes from the alcohol, the second part comes from the carboxylic acid. Excellent, so methyl butanoate is the name for that. Excellent, so not mutanoic acid, methyl butanoate. So that's the name of the ester. One more example then. Let's do pentanol plus methanoic acid. What would that produce? Pentanol plus methanoic acid. Excellent, the person that's given me the answer, well done. And the person that's saying plus water, well done. Yeah, we do always produce water with these reactions. I'm just focusing on the ester for now though. So pentanol, plus methanoic acid. What will that produce? Good, pentyl methanoate. Excellent, well done everyone. So I'll draw one out then. So ethyl ethanoate has your CH3. Your second carbon is the one with the COO, and then CH2, CH3. And what we can see there is, here is the ethyl. This is where it gets a bit confusing, and that's why they don't tend to like you to draw them at GCSE. So this part is the ethyl, and this part is the ethanoate. So the first part of the name goes on the right of the drawing, the second part goes on the left. So just to explain that further, I will draw propyl methanoate. So propyl methanoate has your C double bond O, and here would be your propyl. So effectively it goes from right to left, which isn't what we would expect. And here is your methanoate. So that's propyl on the right. So propyl, 3 carbons, that's propyl, and then methanoate, 1 carbon is here. So that's how you draw it. Any questions on that? Okay, so I've not seen any questions on that. I will draw butyl propanoate as well, just to show you that. So just to show you, it is flipped, not what you would expect. So you might expect that you would draw 4 carbons for butyl, and then propanoate would have the 3 carbons, but it's the other way around. So if we draw our C double bond O first, which is what I like to start with, Then the butyl comes on the right. So there'll be 4 carbons here for the butyl, which remember comes from the alcohol. Like so. And then the propanoate comes on the left-hand side of it. So we would have 2 more carbons because there's 1 already there, like so. So if I just, there you go. So that is butyl propanoate. Okay, so I think that's everything that we needed to cover today. So let's do a quiz. If you go on to Mentee, you should, hold on one second. Oops, not there. Okay. All right, so if you go onto Mentee and type in the code 402694, I think it's a 7-question quiz, and it's everything that we've covered today. So I'm not sure, so there's 29 of you in the webinar, so I'll wait a minute or 2 and then we'll start. And as always, if you've got any questions at all, just pop them into the chat or Q&A function and I'll try and answer them as we're going along. Can I put the link in the chat box? Yes, I can. Go to mentee.com and then you type in 402694. Okay, so I've got 13 of you in at the moment. There are 29 of you in the webinar. So if those of you that can't join, you should be able to see it on the screen as we're going along. I'll wait another 10 seconds and then we'll start it because I'm getting conscious that this webinar is nearly due to finish. Okay, let's start it. Okay, so what do alkenes tend to produce when they undergo combustion? What do alkenes tend to produce when they undergo combustion? Is it carbon dioxide and water, carbon monoxide and carbon dioxide, carbon monoxide and water, or just water? So what do alkenes tend to produce when they undergo combustion? Okay, so we've got 3 seconds left. And the answer is carbon monoxide and water. Great, so 7 of you got that, very well done. So carbon dioxide and water is complete combustion. Remember, alkenes do not undergo complete combustion. Carbon monoxide and carbon dioxide is never produced. You only ever produce 1 carbon product, and so the answer is carbon monoxide and water. Well done. The next question should be coming up in just a second. So butene will react with bromine to produce what? Butene will react with bromine to produce what? I'm not sure why you can't see the answers. Hopefully you can see the answers on the screen. Oh, actually, I just remembered, I think you have to type in the answer for this question. So if anyone's not on the Mentee, you can type the answer in the chat box. Good. So most of you got that right. Yep, so it's dibromobutane, the answer to that, dibromobutane. Well done. Okay, so the next question should be coming up in just a second. So pentene will react with hydrogen to produce what? Pentene will react with hydrogen to produce what? Again, if you're not in the Mentee quiz, you can just send me a message on the chat function for the answer to this question. Good, so the answer is pentane. So remember, this is the one that I like the most because I always find that it's simpler for me to understand. So pentene will react with hydrogen to produce pentane. So well done to those that got it right. The alcohol reaction is when we react with steam. So well done for everyone that tried that one. Okay, so the next question should be coming up now. So the question is, which condition is needed for an alkene to react with hydrogen? So there are actually two conditions needed, but only one of them on the screen is correct. So the two conditions are a catalyst and a certain temperature. On the screen, one of those is correct. So what do we think there? So the answer is the nickel catalyst. So it's actually done at 60 degrees. So the 300 degrees isn't correct. The reaction is done at 60 degrees with a nickel catalyst. Okay, so the next question should be coming up in just a second. What is formed when ethene reacts with steam? So we know that when we react with hydrogen, we produce ethane. When we react with a halogen, we produce di-something alkane. So what was the third reaction? What did it produce? So the answer is ethanol. Well done. Most people got that right. Well done. So ethene reacts with steam to produce ethanol. So all of the alkenes will react with steam to produce ethanol. Well done. Okay, which of these is the formula for propanol? So which of these is the formula for propanol? There's lots of trick ones there, so read them carefully. Good, most of you have got it right so far. Excellent, so it's the first one, well done. CH3, CH2, CH2OH. Excellent, well done everyone. Good job. Okay, let's go on to the next question. Which of these is the formula for butanoic acid? Sorry if the writing is quite small. So butanoic acid. Okay. Good. So far, the pink is the right, so it's the second option that is the correct answer. Well done. CH3, CH2, CH2, COOH. So butanoic acid is the correct answer. That one. The first one is propanoic acid. The third one I don't think is anything, and the fourth one is not anything either. So the carbons and hydrogens weren't right. So well done to everyone that got that correct. I think we're going to see a leaderboard now. So well done to everyone for taking part. You all did a really good job there. This is a pretty difficult topic as well. So well done. Okay. So we've got about 2 minutes left then before we finish. We won't do any exam questions today. As I said, my focus for exam questions will be tomorrow. So we won't do a quiz tomorrow. We'll just be focusing on exam questions. But are there any questions before we finish today? Any questions at all? Butanoic acid is a carboxylic acid. So carboxylic acid, which we looked at here, and all you need to know for today is that they have the COOH bond, the COOH, and it's another group that we need to know about. Someone's asking, what was the reaction where a catalyst of nickel is needed? Really good question. It's the hydrogen reaction here. Sorry, there we go, hydrogen. Nickel catalyst at 60 degrees. Someone's asking if we can do a science joke. I don't know any science jokes, so if any of you know any science jokes, you can put them in the chat and I'll read it out. What GCSEs do you need to study veterinary science in college? There's nothing specific that you need, as long as you've done the 3 sciences and maths and the core subjects, so STEM subjects. Okay, great. I think that's it for today, everyone. Well done for participating and thank you for joining. Tomorrow we'll be looking at alcohol, specifically, so the reactions of alcohols. Someone's given me a joke. They said, what do you call a tooth in a glass of water? A 1 molar solution. That's a good one. If there are any other jokes, you can put them in. Okay, great. Take care, everyone. I will see you tomorrow, first thing in the morning at 9:45. Bye.